Hi, my name's Alan Smith. This webcast is going to provide a quick introduction to the Red Dog Racing scenario that I've been working on for a number of months. The Red Dog Racing scenario is based on a driving game, which is an adaptation of the XNA Racer sample game for the XNA platform. Windows Azure is also an important part of the scenario. We're going to be leveraging a number of Windows Azure services developing the scenario. And by doing so, we'll be exploring the different ways that we can integrate the racing game with the services hosted in Azure. This diagram shows a high-level architecture of the implementation. We're currently using components in the Windows Azure Service Bus, worker roles in Windows Azure Services, table storage and blob storage in Windows Azure Storage, and also a Windows Azure website. The driving game is going to be sending lap timing data and telemetry data onto a topic in the Windows Azure Service Bus. We then have a worker role that's going to dequeue these messages from the subscriptions, process the data, and insert entities into tables in Windows Azure Table Storage. As the number of players of the game increases, we can scale a worker role tier to be able to process larger volumes of telemetry data. And the site hosted in Windows Azure websites can display the overall standings, the lap times, and the telemetry data for the drivers. So let's see the scenario in action. You can see that I've got two applications running, the Red Dog Racing game and also a driver tracker that's written in Windows Presentation Foundation. The driver tracker is going to show the live position of the cars on the tracks, so I'll position the windows so that we can see both applications. Now in the driving game we've got a high scores feature, and you can see the fastest times that have been set by different players for the different laps in the driving game. This data is stored in Windows Azure Table Storage, and the game is retrieving it through a REST service. So I'll select to start the race and choose a car. There's 3 cars to choose from, and I'll select the Windows Azure car. And I'll take the beginner track to start with. Now as I start the lap, you can see that there's other ghost cars on the track that are driving alongside me and in front of me. Every time a driver completes a lap in the driving game, the replay data is going to be saved into Windows Azure Blob Storage. So I'm actually racing against the replay data from other players who've driven around this lap. One of the changes that I've made in this game is to rewrite the physics engine. And I've also modified the tracks to put a few jumps in the track. And this can be fun to test the skill of the drivers, and it can also be fun to see the other ghost cars flying off the track and crashing into the landscape. A couple of other features I've added is a kinetic energy recovery system or a KERS system, and a drag reduction system or DRS. The KERS system acts like a battery pack in a hybrid car. I can use it to get a boost in acceleration at strategic points in the lap, and the battery will be recharged when I use the brakes to slow down for corners. And this adds a bit of strategy into the game. The DRS, or drag reduction system, allows me to change the aerodynamic properties of the car. Enabling DRS will dramatically reduce the amount of aerodynamical drag, which means that the car will be able to accelerate to a much higher top speed. However, enabling DRS will also drastically reduce the amount of downforce on the car, and this will affect the cornering performance, meaning there's much more chance of the car sliding sideways as we go into a fast corner. As I'm driving around the lap, you can see that the car's position is being updated in near real time on the driver tracker. And when there's a number of different players playing the game, you'll be able to see the players' positions on the 3 tracks as they're driving around the track competing for lap times. So I'm coming up to the end of the lap now, and now it's complete, and I've set a time of 1 minute 22.13 seconds, and that's put me in 9th place. As I mentioned, I'm making extensive use of Windows Azure Storage in this scenario, so let's take a look at how the data is stored. In the Red Dog Test Windows Azure Storage account, in the Replays blob container, you can see that I've got a number of blobs, and each one of these blobs is the replay data for a completed lap in the game. And it's this data that's used to generate and animate the ghost cars in the game. In the Test 02 Lap Times table, I'm storing the lap data for all of the completed laps, and it's being ordered with the fastest lap time first. You can see the lap data for the 3 different tracks here. You can see that the different track lengths have different numbers of sectors in them. Selecting one of the telemetry data tables will display the telemetry data, and I'm sampling this data 10 times a second for every lap that's driven in the game. You can see the type of data I'm sampling, the car position, the car direction, acceleration, downforce, drag, engine force, forwards velocity. I'm basically tracking a lot of details from the driver input, from the game itself, and from parameters in the game's physics engine. So let's check out the website for the game. You can see that the website's displaying the overall positions, and we can also go into the beginner, advanced and expert and see the best times that have been set for the players in the lap. Selecting one of the lap times allows us to view the telemetry data graphically. You can see the speed of the car through the lap, And you can also see the driver input, the KERS battery, throttle, brakes, and the use of the DRS and KERS system during the laps. And this allows us to look at the telemetry data for another driver's lap and see why they were faster than us. As I mentioned in the intro, I've been working on this scenario for a number of months, and I'm going to continue working on this scenario and improving it. So if you want to learn more about game services and telemetry in Windows Azure, you can follow this webcast series.